Hello guys, I just want to share with you what I have learned on network management, and now my first I discuss is all about network policies and standards. Let's talk about network policies. A network is a complex system to ensure that it runs smoothly and to ensure that everyone involved in running the network, the network manager and technicians. For example, know whose job it is to do what. A network will have a number of written policies in place. This will have been drawn out by the network manager, usually consulting with everyone. These include acceptable use, disaster recovery, backup, archiving, and failover policies. The first is acceptable use. Acceptable use is people who need access to a network to do their job are usually asked to sign an agreement that they will only use it for legitimate reasons related to doing their job before they are allowed access. Next one is disaster recovery policy. All networks might have a disaster. This could range from the entire building holding a network burning down to flood damage to malicious damage by a hacker or disgruntled employee. And then backup policy. All data is at risk at all times. There are many reasons why this is so. A hacker or disgruntled employee may delete data. There could be a fire. Data might get corrupted by software or an upgrade. A piece of equipment like a hard drive might fail. There might be an earthquake or other natural disaster. Someone might steal a computer with data on, and so on. Also, archiving policy. Sometimes you don't want to have certain files on your system anymore, but you don't want to just delete them, or you're not allowed to legally. And the last is failover policy. Companies have second devices in place for key pieces of equipment on a network in case the first device fails. Let's talk about network standards. Network standards are also ground rules that are set by commissions so that hardware is compatible among similar computers and assures interoperability. This is done to ensure that backwards compatibility and compatibility from vendor to vendor. And that's all for the network policies and standards. Now this is what we call OSI reference model. OSI stands for Open System Interconnection, is a reference model that describes how information from software applications in one computer moves through a physical medium to the software application in another computer. The OSI divided into two layers, the upper layers and lower layers. These are the 7 OSI layers. The first one is physical layer. It provides a physical medium through which bits are transmitted. Data link layer. It is used for error-free transfer of data frames. Next, network layer. It is responsible for moving the packets from source to the destination. Transport layer. It provides reliable message delivery from process to process. Session layer. It is used to establish, manage, and terminate the sessions. Presentation layer. It is responsible for translation, compression, and encryption. The last is application layer. This layer provides the services to the user. Now, let's talk about the peer-to-peer network. Peer-to-peer network operating systems allow users to share resources and files located on their computers and to access shared resources found on the other's computers. Peer-to-peer networks are designed primarily for small to medium local area networks or LAN. And then another is client-server network model. Client-server network operating systems allow to the network to centralize functions and application in one or more dedicated file servers. The file servers become the heart of the system, providing access to resources and providing security. And this is the transmission and networking devices. Analog transmission. To send data, digital data over an analog media, it needs to be converted into analog signal. Also, digital to analog transmission. When data from one computer is sent to another by some analog carrier, it is first converted into analog signals. Analog signals are modified to reflect digital data. Next one is analog to analog conversion. Analog signals are modified to represent analog data. This conversion is also known as analog modulation. Analog modulation is required when bandpass is used. Then, digital transmission. Data or information can be stored into two ways, analog and digital. For a computer to use the data, it must be a discrete digital form. To transmit data digitally, it needs to be first converted into digital form. The next is digital to digital conversion. This section explains how to convert digital data into digital signals. It can be done into two ways, line coding and block coding. For all communications, line coding is necessary, whereas block coding is optional. Another is parallel transmission. The binary bits is organized into groups or fixed length. Both sender and receiver are connected in parallel with equal number of data lines. Both computers distinguish between high order or low order data lines. That's all guys for the discussion, for sharing what I have learned for us. And it's me, Batang Reymark from BSIT 2A. Thank you.